Welcome to today's video. We're going to look at how data models and queries intersect in a slightly different way than you're probably used to doing. Many years ago, there was a couple of queries in our data warehouse that were performing extremely poorly. So poorly, in fact, that nobody used the views that the queries were encapsulated in. DBA had spent quite a while trying to perfect the performance and was getting absolutely nowhere. They threw up their hands, they tossed it to me, and so the first thing I did was to generate a data model that represented the query as it was written so I could get an understanding as the intent of the query, some of the objects that were underlying the query, and how they were being brought together from a relational standpoint. And having seen that, I then indicated exactly where they had made a poor choice in a relational substructure within the query. Solving that then made the query perform much better. Fast forward a number of years and started using Alteryx and realized that you can bring the query directly into Alteryx, but that doesn't give you all of the power of a tool such as Alteryx in doing your data analysis, preparation, and cleansing. And so I started using data modeling to understand how these queries can be broken apart and then put back together inside of the Alteryx tool or another tool. So that brings us to today's little problem statement, and that is that a data analyst was given a SQL query that was being used in some of the ad hoc reporting, and they needed it to be rewritten inside of Alteryx so that it can be a much more extensible and modifiable process. But they didn't really know how to take apart that query to understand what they had to do inside of the Alteryx workflows, because inside of Alteryx, you bring in individual sources of data, figure out how to blend and manipulate and cleanse them, and go on from there. Making matters worse, and this is another problem that we run into all the time, is that they have access to the data in a third-party applications database, but they really don't have full access to where they can do any kind of true data modeling and data analysis. And so they wanted to find how to progress in this. And I said, well, what we need to do is build a data model that's based not on the relationship of the data, but on the relationships within the query, so you can understand how that data is being brought together. And that will give us, from this model, some insight into the application data that's out there. We can identify places that need to be improved or fixed, and then they can utilize that model and that understanding in order to design their Alteryx workflow. It's always nice to talk about some problems with SQL statements, and it's why you would want to sort of stay away from it. Again, I will never discount the power of the SQL select statement. It is an extremely powerful tool, especially with all the additional functionality that's been given to it over the years by the RDBMS companies such as Oracle and IBM. But writing effective queries, not just writing a simple query, but really writing a complex query that is effective, requires a skill set that will take you a long time to obtain, much longer than obtaining the same skill set within a tool such as Alteryx or other ETL data cleansing and blending applications. Second thing is that when someone writes a query, they understand it when they write it. They probably don't understand it a year later, but they understood it when they wrote it. And if you don't have an adopted standard of how to write your queries, then a year later, or a new person coming along, you suddenly don't know exactly what's going on. And so if you're doing a lot of SQL queries, and it's the standard of your organization, looking at a coding standard is definitely the first step. And if you need that, go ahead, subscribe, drop me a comment, and I can share a coding standard with you through another video that I adopted many years ago basically just for myself so that I was always doing it the same way, but then it became a group standard as well because everybody began to share information. Anyway, that's a long bullet point right there, but SQL queries are also very not performant. So you can write a very simple query or complex query against a small set of data and it works great. You take it into production 1 year later, it is not running because the data set got so large. So a simple query or a simple data set, as it expands, suddenly does not linearly become more expensive. It becomes geometrically more expensive. Also, I have discovered, and people always wonder why I do this, they hand me this god-awful complex query and say, hey, we just need to add this one table into it. Can you just simply add that table? We don't see how to. And I end up spending 4 days rewriting the entire query because you can't just plug in another table into some of those complex queries that you've written. You really have to think about the overall structure. That being said, let's take a look at this query that was handed to us. It is, to a degree, looks basic, and if you want to break down a SQL query, you have what becomes between the part of that is part of the select, which is just simply the data, and we can basically ignore all of this for our data modeling because this tells us what to do with the data once we get it, but the relationships of the data is found down here in the table list, which is the from and the joins. We have a from, that's just the primary table that we start with, which may or may not actually be the one that it gets started with within the query itself, but at least the way they thought about it. And then we join an inner join, outer join, left joins. Keep in mind that a join is an inner join. Down here they use an inner join, which might confuse you. And then they have some left joins, and left joins are really left outer joins. And then finally you have your where clause and your order by, and again we can ignore this piece of it because what we're concerned about is what's right here in the middle. And so then I will simply bring this up and isolate it. So here are all the tables. Here are the columns that the tables are joined on, which is the beginning of our relational model. And this is the only piece of this query that I need to focus on. You might have an extremely sub-queried query, which is where you have a queries within queries, or rather than just simply joining to a table, you join to a query. Some other structures that you can nest as well, but at the end of the day, you're just simply looking at what are the tables that are involved in this query and what are the criteria that we put them together, and that becomes our data model. So to walk you through this, I bring up my modeling tool. Now keep in mind that data modeling tools typically have rules. The relational rules allow you to build a relational model, and so there's some limitations to what you can do effectively. But again, what you're trying to do is present it pictorially so that you can see what's going on and analyze it and share that information with other people, not to actually build the tables and objects themselves. So we're going to try to avoid violating a lot of rules, but in the end of it all, we just want to get the piece of information out here that we can see. So the step that I've already taken is I've gone ahead and created all of the tables just by the names of what was listed there. And we found out from this query that they were using the Daisy department twice in this query. So we only have to represent it one, and it'll relate itself to 2 other tables. And here is the main table, which is the Veterinary Hospital's encounter table, which is when a puppy comes to the hospital. So let's go ahead to a blank slate. I've already developed this model out, and so rather than have you watch me type and have typos, we will just simply draw in objects and talk about them as we show how the relationships came about from within the query and becoming a model. So we want to start with the vet encounter hospital table. You will notice that there is a number of attributes already in this, and so we will ignore them as we go through. But the first relationship that we came up with in the query had to do with the flow sheets, which has to do with how the puppy was taken care of. I was going to say managed, but taken care of at the hospital, what tests and other uh, events occurred. So let's go ahead and bring that table in. It was the first one that this is the primary reason they put this together. And so what we saw here very quickly is a direct relationship to whereby we can see that the inpatient data ID could be considered, again, could be considered the primary key, but a driving influence of this table. And it has a direct relationship into this inpatient table with the inpatient ID. So we just simply draw that relationship in, knowing that we are now joining. We've left this as the primary key in this table so that we know that it is the inner join. Secondarily, we're looking through the query, we see that there is another table associated with this, which creates this third normal form relationship between the actual measure and which is the event tasks, whichever, associated with that puppy being at the veterinary hospital. And it's the relationship that we draw between the puppy's stay and a known procedure. Now, typically, if I was actually looking at this data, I would believe that this data is part of the primary key, the FSID, which is in both of these tables. But because this is done as an left outer join, I've left it as a non-identifying piece of information so that we know, because of the 0 here, that this is an optional relationship within this data. I sort of question that, but I can't tell you for sure that that's what's going on. And we'll have a summarization of some of the things I found, but so now I see that we have this duality relationship. This is an intersection table, if you wish to call it that, because it shows a match between the puppy and the actual task that is taken care of or seen at the hospital. We need to know some information about when the puppy came in, and that comes about from the, there it is, the inpatient hospital admission table. Now this is where the data began to separate, and we sort of started to question exactly how this data comes about, how it's identified. We see that we have a relationship between these two tables that is used by this CSN ID. And so what this becomes is an alternate ID within this data set as well, so that the encounter is not only identified by the inpatient data ID, but also the encounter CSN ID. And that relationship goes into the admission record here. And what we know is that it's a one-to-one relationship. In other words, when he is this relationship between these two because of the way that we see the data structured. Now this is hard within this data modeling tool to actually show this, but we did so by putting in here that you have a foreign key. And since this was a left join in that data, I'm not so sure that every one of these has an admission, which I would think it does. Again, we'll summarize this at the end of it later. So I left this as a nullable column to show that this is an alternate relationship in here. This also leads us to another table, which is the account information, which I'm assuming is from the billing standpoint. And what we notice from the vet account is that in the query, the veterinary account is also an inner join, so that there is a direct relationship and an existing relationship between the puppy at the hospital and the accounting piece of information here. So this is shown as the primary key within this account and a direct relationship and a mandatory relationship between these two. One of the questions I have is the relationship not really supposed to be between these two tables? And if it is, it would make this query work a little bit better so that the encounter has an admission, the admission has the account. So it's some of those things that you could look at cleaning up as we go through it. We have two final tables that are also just simply lookup tables. We have the department table, and that we noticed when we were going through this data that it was being used twice in the query. Again, just as we go through this, I thought it might be nice just to go pop and see that all that I'm doing is walking down through these tables and looking at the inner join or the outer join that is being used, and then the criteria that they're using to connect these two together. That's the on clause. I'll pause for 5 seconds so you can take a look at it. Quick 5 seconds. So what we have is two relationships, both of which were part of outer joins, which I don't quite understand why that would be, but that's again places for questions, so that the Veterinary Hospital encounter has a department ID associated with it, as well as the admission has a department associated with it as well. Again, questions about why this duality is in there, but there's just lookup data goes into both of these tables. And then finally, we have the current location table, which has a location ID that applies to the department, and it has a relationship going into the revenue location ID. So this will give us more information about that location. And this also is being used as an outer join. So it is indicated by being nullable here. And the 0 or the open circle within that relationship diagram. So this paints what's not a very clean picture, but at least gives us an idea of what's going on and possible places to ask and follow up questions. So now I have an understanding of the tables and relationships between those tables to help drive how it is that I wish to design and bring this data together. But as I mentioned before, it also brings up a couple of questions, which is the whole reason we did this. So within this model and looking at it, two pretty simple questions came up right away, which is, are all the outer joins necessary, or there's a way that we can use an inner join to make the overall processing much more efficient? And there's a couple of those in there where I question if that actually is what it is that we decide that we want to do, especially when we start to validate the data with a filter. And that there are two related sets of data, one based on what would be considered a primary key, and a second which is being based on an alternate key. And that is where we have the encounter CSN ID through one of the tables, and then we have the inpatient data ID through the other table. Is that the most efficient way to run that data? And is there ways that we could make this overall processing a bit more efficient by understanding how that relationship exists and whether or not it is a limiting relationship within the data that we are querying? Not trying to solve that here because we're not going to be looking at the data, but this is simply where your next step comes in when you're trying to build this workflow and get a design going on. But at least from doing the data model, you're able now to see where those questions are and to do some further research into the specific data as well, and talking to your business expert, subject matter person, or the developers of the applications if you have someone there that you can talk to. So I hope this shows you a way to work with your SQL queries and not just simply embed them in your workflows. Another usage for a data model, which I do most things in data models because I'm a very pictorial person. So go ahead and subscribe to my channel as we follow up on this subject as well as other subjects to help you with your journey within data and data analytics. Have a great day. Thank you.